Hello students, welcome to the new session. In this session, we are going to discuss about simple pendulum. Simply about the simple pendulum of a simple harmonic motion. What is a simple pendulum? A simple pendulum which consists of a small bob of mass m. A small bob of mass m. And which is attached to a inextensible string. Means we are considering a string that is not able to extend, inextensible string of length L. One end of the string is attached to the rigid support. One end of the string is attached to the rigid support, and another end of the string is joined to the bob. One end of the string is attached to the rigid support and another end of the string is attached to the bob. Then we can consider this is as length of the pendulum. This is as length of the pendulum. Length of the pendulum L, and this is mass of bob. Mass of bob. And now here what we will do, that is having radius, means a radius negligible, and this is length L, and it is oscillating about the rigid point, and that we can say that simply simple pendulum. Simple pendulum consists of a bob of mass m and which is attached to a string of length L and suspended from a rigid support, which is simply named as simple pendulum. And simple pendulum which is undergoing two simple harmonic motions. One is linear simple harmonic motion. What is that? Linear simple harmonic motion. And the other one is angular simple harmonic motion. Angular simple harmonic motion. Linear simple harmonic motion and angular simple harmonic motion. What is a linear simple harmonic motion? So means in linear simple harmonic motion we consider only the force, whereas if it comes to the angular simple harmonic motion we will consider and torque. We can consider the value of torque. So let's see how we are calculating it. This is a pendulum of length L, pendulum of length L, and which is undergoing the simple harmonic motion. So this we can treat it like at any position, and this position which is making an angle theta with the vertical, Generally we said that this is the weight mg, and here actually it is the weight mg. Here it is making an angle theta, right? And that can be resolved into two components, mg cos theta and as well as mg sin theta. This value mg sin theta, this is mg only, and this is mg sin theta. Now every situation the particle or the bob is always coming to the main position, because of the restoring force. What is restoring force? The force which required to bring the particle towards its main position. That's we are named as restoring force. The restoring force is equal to what we are taking simply mg sin theta, which mg minus mg sin theta. Why? Which is acting always towards the main position. Now we can take the value of ma, means mass of the bob, into its acceleration. That is equal to minus mg sin theta, then mm cancel, then a is equal to minus g sin theta. For example, this is the length L and we consider the displacement as x. For the small values of theta, for small values of theta, small values means actually in exactly simple pendulum or simple harmonic motion we are taking the small angular amplitudes only, small angles only. If it is taking the large, then that is different. Small amplitudes only it can able to bear. So that's why we are considering for small values of theta. For small values of theta, what we are writing, sine theta is equal to, simply sine theta is equal to, which is nearly equal to theta. Sine theta is equal to, nearly equal to theta. And the theta value means this is theta and this we are considering like x and this is L. So theta is equal to what we can write, x by L. Arc length upon radius, x we can consider like arc length upon radius. Theta is equal to x by L. X is arc length, L is length. Now if you put in the place of A is equal to minus g sine theta. In the place of sine I am taking a theta, then minus g into x by L, minus g into x by L, then A is equal to minus g by L into x, minus g by L into x. We know that acceleration is directly proportional to displacement in opposite direction. And also we know that according to the simple harmonic motion condition, A is equal to minus omega square x. We know that, what we know that? A is equal to minus omega square x. We know that A is equal to minus omega square x. Let's compare both expressions. Compare both expressions. Compare equation 1 and equation 2. If we are comparing both expressions, what we are getting here? Omega square is equal to g by L. Omega square equal to g by A minus minus x x. Then omega square is equal to g by L. Then omega is equal to under root g by L. Then if you are taking the time period, t is equal to 2 pi by omega, then time period t is equal to 2 pi into under root L by g. This is the simply time period of the simple pendulum. Means for this only we are solving this all. Time period of the simple pendulum. And if you are asking frequency, frequency is the reciprocal of time period, that is goes to 1 by 2 pi into under root g by L. 1 by 2 pi into under root g by L. That is the frequency of the simple pendulum, and this is the time period of the simple pendulum when we are taking linear simple harmonic motion. When we are taking linear simple harmonic motion. So that is the time period. Next, instead of linear simple harmonic motion, if I am considering angular simple harmonic motion, then what will happen? Then what will happen for the angular simple harmonic motion? So here what we have to consider, instead of the restoring force, I'll consider restoring torque. Restoring torque. Torque is equal to what we are writing, force into perpendicular distance, and this also acting towards the center only. This is also acting towards the center only. So again what we are writing, mg sin theta into L, mg sin theta into L. And here torque tau is equal to what we can able to write, I alpha. Torque tau is equal to what we can able to write, I alpha. I alpha, which is equal to minus mg sin theta into L. Again for the small values of theta, for small values, values of theta, small values of theta, what we can able to write, sin theta, which is nearly equal to theta. Sin theta is nearly equal to theta. That means what we can able to write, I alpha is equal to minus mgl into theta. Minus mgl into theta. Then alpha is equal to minus mgl upon I into theta. Alpha is equal to minus mgl upon I into theta. So you can able to learn anything of linear simple harmonic motion or angular simple harmonic motion, anything, both you are getting same, but here just I am explaining the process of solving, that's all. See, where alpha is called angular acceleration. What is that? Angular acceleration. Angular acceleration is directly proportional to angular acceleration is directly proportional to angular displacement in opposite direction. Angular displacement in opposite direction means alpha is equal to what we can able to write minus omega square theta. Alpha is equal to what we can able to write minus omega square theta. If you have any doubt, actually what is the definition of angular acceleration? What we are writing? Alpha into r. What we are writing? Displacement theta into r. If you are taking r cancel, then alpha is directly proportional to theta. So now just compare both equations. If you are comparing both equations, comparison. If we are comparing that, then what we are getting? Omega square equal to mgl upon I. What is I? I is moment of inertia. Moment of inertia. Mass m, length l. Then moment of inertia. How much you will get? How much you can get? That is ml square. So then omega square is equal to mgl upon ml square. L will be cancelled. Then omega is equal to under root g by l. Omega is equal to under root g by l. Then what about the time period? Time period is 2 pi upon omega. That is equal to 2 pi into under root l by g. 2 pi into under root l by g. And frequency 1 by 2 pi into under root g by l. Observe what we got. Same we got. Same. Whatever time period or simple pendulum. Time period of simple harmonic motion. Simple pendulum in case of linear simple harmonic motion or angular simple harmonic motion. These are the two processes. Which one you have to take? Anyone, no problem. No, there is no compulsion. You have to solve this only. So one more thing, very important thing. Simple harmonic motion time period is 2 pi into under root L by G for smaller amplitudes. Smaller amplitude. If the amplitudes are larger, this is asking in JEE Advanced. So that's we will discuss in the JEE Advanced session again. The time period is also depends upon acceleration due to gravity. It is also depends upon length of the pendulum. So means if the length is changes, then time period changes. If acceleration due to gravity changes, then also time period changes. And here we are considering one pendulum that is called as seconds pendulum. Seconds pendulum. What is seconds pendulum? The pendulum whose time period is equal to 2 seconds. The pendulum whose time period is equal to 2 seconds. That is called simply seconds pendulum. So what is that? Time period is 2 seconds. The pendulum whose time period is equal to 2 seconds. 2 seconds. So then 2 is equal to 2 pi into under root L by G. So then what we can take here? Pi 1 is equal to pi into under root L by G. If you are squaring on both sides, then you can take G by pi square is equal to L. What is the value of G? 9.8. What is the value of the pi square? Nearly you are getting 9.8 only. You can take 3.14 into 3.14. Then the length of the seconds pendulum is 1 meter. What is the length of the seconds pendulum? 1 meter. And if you are taking that observation of the variation of the L and how it will be varies, and variation of G, how it is varies, we can take with variation of G. Variation of G. Now what I am considering here, the pendulum is I am fixing in a lift. Where? In a lift. Lift is accelerating upwards. Lift actually. Lift. This is the lift. And lift is accelerating upward with an acceleration A. Lift is accelerating with an acceleration A upwards. Whenever the lift is accelerating upwards, we know that what happened to the weight, upright weight. What happened to the weight? Weight is increases. So that means the effect of the gravity, you are getting the effective acceleration G plus A. The effective acceleration is G plus A. Why? We know that. So here acceleration is upwards, gravity also upwards. both are acting in the same direction. That's the resultant acceleration what we are getting, G plus A. If you have the doubts, you can go with the formula. Net force equal to applied force minus opposing force. Yes. So then time period of the pendulum, how much you are getting? 2 pi into under root G by A. L upon G by A. G plus A, sorry. That means when the lift is moving upwards, what is the effect of the gravity? Increases. Then time period decreases. Time period decreases. Important questions are asking from here. How it will be act? How it will be act? Next, second condition. And if the lift is moving downwards, the lift is moving downwards or accelerating downwards. Accelerating downwards with an acceleration A, accelerating downwards with an acceleration A, then G effective will be goes to simply G minus A. G minus A. When the lift is going upwards, G plus A. When the lift is going downwards, G minus A. Here what will happen in the first case? Time period decreases. Time period decreases because effect of gravity increases. And here time period is going to be 2 pi into under root L upon G minus A. 2 pi into under root L upon G minus A means effect of the acceleration decreases. Then time period increases in this case when the lift is accelerating upwards. Lift, accelerating upwards. Here accelerating downwards, accelerating upwards and accelerating downwards. And let's see the third case. Lift is moving with constant velocity, nothing but uniform velocity. Uniform velocity. When the lift is moving with uniform velocity, then what happens? Uniform velocity or rest also, no problem. Or at rest. So then what will happen? The effect of the effective gravity is G only, because there is no any other acceleration, because if it is moving with uniform velocity, its acceleration 0. If it is a rest, again acceleration 0. So that is G. Then time period is say 2 pi into under root L by G. 2 pi into under root L by G. And also if it is freely falls, lift is freely fall. Here some cases are there. Not only lift freely fall, and lift is in at the center of earth. And the lift, pendulum at the center of earth, or else freely falling if the pendulum is in the freely falling lift. Or else in this one more case, if it is in artificial satellite, the pendulum is in artificial satellite. When which is in artificial satellite, so what happened when which is in artificial satellite? So in this all cases gravity is 0. In this all cases, you may say that here gravity 0. Here what happened? Here which is effective gravity. Freely falls means what happened? Gravity G minus G. Effective gravity will be 0. In case of at the center of earth, gravity 0. In artificial satellite, gravity 0. In gravity free space, wherever you can take the gravity free space, what is the time period of the pendulum? The time period of the pendulum is goes to 2 pi into under root L by 0. Is something upon 0, how much you are getting? Infinity. The time period of the pendulum is going to be infinity in case of these places, where in freely falling lift, or else at the center of earth, or else in the artificial satellite. And they may ask the question how it is moving. So actually if you are trying to drop here, due to the effect of the gravity, the bob is coming. If there is no gravity, the bob will move in here and here, anywhere that can able to move, So that is simply the time period of this particular conditions. Very, very important and as well as easy situations. Let's see one more application. Whenever we have the pendulum in a horizontal accelerating vehicle, so here a vehicle is moving on a horizontal road with some acceleration A. with some acceleration a. So then what will happen here? One thing, gravity is acting vertically downwards and acceleration is acting horizontally like this. Then the effective acceleration, the effective value of g, the effective acceleration what we are getting, the effective value of g is going to be under root g square plus a square. Under root g square plus a square. So then we can get here the time period is 2 pi into under root L upon under root g square plus a square. This is the time period of the pendulum when the pendulum is in horizontal accelerating vehicle. Horizontal accelerating vehicle. Horizontal accelerating vehicle. Which is in horizontal accelerating vehicle. So then the time period of the pendulum is this much. In case vehicle is on inclined plane, accelerating downwards. So actually what is the acceleration of the inclined acceleration is g sin theta. So but here some pseudo acceleration is acting now. How much? G sin theta in which direction? Upward direction. G sin theta. And here, so this is the gravity. And what is the angle between them? The angle between them will be goes to here. What is the angle? 90 plus theta. 90 plus theta. Angle between G and G sin theta. And students are making one common mistake here. They are forgetting the gravity value. They are forgetting the gravity value and they are writing only T is equal to 2 pi into under root L by G sin theta. But actually it is wrong, because G sin theta is the acceleration of the vehicle, but also gravity also is acting. Gravity also acting. So that's why you have to take the effective value of the gravitation. What is that? Effective value of the gravitation. What is the effective value of the gravitation? Let's see here. The effective of the value of the gravitation you can able to take here. These are the two vectors are making some angle. Then what we have to take? Vector law of addition. Vector law of addition. The effective value of the g cos theta is equal to what we are writing? A square plus b square plus 2ab cos theta formula. In vector law of addition we are using. Now see here, A is I am considering like g square. B is I am considering like g sin theta. G square sin square theta. Plus 2g into b is nothing but again g sin theta. Nothing but g square sin square theta into cos of 90 plus theta. Cos of 90 plus theta. Cos 90 plus theta. What is the value of cos 90 plus theta? Minus sin theta. Minus sin or minus sin. So sin plus sin. Sin square. So you can see here what you have finally. The g effective is equal to what we are getting. G square you can able to take common. Then 1 plus sin square theta. And here cos 90 plus theta. Minus value. So the totally value is going to be, how much it is going to be? Totally 2 sin square theta. So sin square theta minus sin square theta means how much you are getting? The value is goes to 1 minus sin square theta. 1 minus sin square theta means cos theta. So then g effective value how much you are getting? G cos theta. Then time period t equal to 2 pi into under root L by g cos theta. It is not g sin theta. How much it is? G cos theta. It is not g sin theta.